Hello and welcome. I'm going to go through a past paper question on transition metals, A-level chemistry, year 2, taken from the AQA specification. Details are in the description. Before addressing the question, I will expand on the theory covered in each section. Let's get started. Here's the first part of the question. Solution A contains the compound CuH2O6Cl2. State the type of bonding between the oxygen and hydrogen atoms in this compound. Both covalent bonds and ionic bonds exist in this compound. A dative covalent bond is a special type of covalent bond in which both of the electrons that are shared come from the same atom. Another name for a dative covalent bond is a coordinate bond. Each water molecule makes a dative covalent bond with the central metal cation. The coordination number of this complex cation is 6. Ionic bonds exist between the complex cation and chloride ions. Each water ligand is just an ordinary molecule of water. Covalent bonds exist between the oxygen and hydrogen atoms in this compound. Here's the next part of the question. State why the chloride ions in this compound are not considered to be ligands. A ligand is a species that donates a pair of electrons to a central metal cation to form a dative covalent bond. Chloride ions can act as ligands in other compounds, but this isn't the case here. Chloride ions are not acting as ligands because they are not donating a pair of electrons to form a dative covalent bond to the central metal cation. Here's the next part of the question. An excess of ammonia was added to a sample of solution A to form solution B. Write an ionic equation for the reaction that occurs when solution A is converted into solution B and state the colour of solution B. There's no easy way to say this. You have to know the reactions and the colours of transition metal complexes. 4 molecules of ammonia replace 4 water ligands to form a deep blue solution. Finally, we have to balance the equation. Here's the next part of the question. Aqueous sodium carbonate was added to another sample of solution A to form a blue-green solid C. Identify the blue-green solid C. If you know the colours associated with the reactions of transition metal ions, this question is straightforward. Cations with a 2+ charge form the metal carbonate precipitate. It's also worth memorising the associated equations. You should also be aware that metal cations with a 3+ charge react differently. The greater charge density of the 3+ ions weakens the OH bonds in the water ligands. Metal 3+ ions make slightly acidic aqueous complexes that react with carbonates to form carbon dioxide. Here's the next part of the question. Reagent D was added to another sample of solution A to form a yellow-green solution. Identify reagent D and write an ionic equation for the reaction that occurs when the yellow-green solution is formed from solution A. Once again, knowing the colours of complexes is vital for this topic. The only yellow-green solution that copper 2+ forms is CuCl₄ 2-. Concentrated HCl must be used to provide the Cl- ligand. Once we have the reactants and product, all we have to do is balance the equation. If dilute aqueous HCl is used, water molecules will not be replaced. The reaction is actually an equilibrium. This reaction involves a change in coordination number from 6 to 4. Chloride ions are larger than water molecules. It is only possible for 4 chloride ions to fit around the central cation. Here's the final part of the question. Explain why colorimetry cannot be used to determine the concentration of solutions containing CuCl₂-. in your answer refers to the electron configuration of the metal ion. Colorimetry can be used to determine the concentration of coloured solutions. The more concentrated a coloured solution is, the more light will be absorbed. This is measured at a specific wavelength depending on the colour. Coloured solutions arise due to transitions of electrons from ground states to excited states within incomplete D subshells. This compound contains a Cu+ ion. We can see from the electron configuration that the D subshell is complete. CuCl₂- is colourless. Well, that's enough from me now. Thanks for watching. Comments, questions and suggestions are always welcome. Do the usual to get notified about the next amazing video. Take care and goodbye.